Okay, let's hope it doesn't freeze again. All right, so we left off right here, okay? And now what we have to do is simplify this. So this negative exponent needs to come down in the bottom. So what we have is 12 over 5x to the 2/5 minus 8, what is it, 8/5? 8/5 x to the 3/5. Yeah, this stays in the top. The deal here is we need critical numbers, and this is going to become a rational function. So I need a common denominator because it needs to be one function. And remember, critical points or critical numbers come from where you set the numerator and the denominator equal to 0. What is my common denominator?
5x.
Yeah, 5x to the 2/5. Nice. Okay, so do I need to do anything to this first fraction? No, I leave it alone. It's totally fine. So this would be 12 minus. So then I need to multiply this by x to the 2/5 over x to the 2/5. So I've already got the bottom. What is x to the 3/5 times x to the 2/5? X to the first power because it's x to the 5/5, right? So this is just minus 8x. Okay, so this is f prime. Okay? So what we want to do is set the numerator and the denominator equal to 0 because we're looking for where f prime is equal to 0. That's in the top, and where f prime is undefined, okay, meaning the denominator, right, because we can't have a 0 on the bottom. Okay, so my critical numbers are where x is equal to, can we say 0? That's the easy one, denominator, right? And then set the numerator equal to 0 and simplify. So it's 12 over 8, so 3/2. Help me out. 12 over 8 reduced by 4. 3/2. Jackson's like, you're the teacher. Like, you should know that. I'm teasing. He didn't. He didn't. I was joking. Okay, everybody okay? These are critical. These are critical numbers. Sorry. Yes? Okay, so now we need to test them. Test. I totally threw you under the bus, man. Sorry. It was a joke. So here we are at 0. Here we are at 3/2. This you cannot use the multiplicity rule. Okay, because it's a rational function. Okay, they're not factors. So that's totally different. So if we pick a negative value, plug in -1, remember you're plugging into the derivative here. First of all, here's my question. If I plug in any value to the denominator, even if it's negative, let's use -1. What's the 5th root of -1? -1. What's -1 squared?
1.
Okay, so what's going to happen to anything in the denominator because we're going to square it? It's going to become positive. So can I ignore the denominator and just use the top? Does everyone understand what I just did? Because it's squared, it will always become positive no matter what you do. Okay, a positive, a negative, a 0, well, that won't be, but it won't be equal to 0 because it's a critical number. Okay, so when I plug in -1, what do I get in the top? Positive or negative? Positive. Okay, good. Plug in, can I just plug in +1 because this is 1.5? Okay, what do I get? Ooh, positive. This is a great example. Plug in 2. Negative. All right. Everybody good with the test? Yes? Okay, so this is what we're looking at here. Tell me about f of x from -infinity to 0. Increasing. 0 to 3/2. Ooh, okay, and then from 3/2 to infinity. Okay. So what do we have here at 3/2? What is this? Relative who? Max.
Oh, yeah.
Yeah. The other one. Relative max. Okay. Relative min? No, we don't see anything. What's up, Jay?
Never mind. I'll just let you continue. See if it answers.
See if it clicks? Okay. So when we write our conclusion, we would say by... I said write small. You made me freak out. I thought it froze again. By the first, I don't know, borrow space somewhere else. First derivative test. we'll say F has a relative max at x equals 3/2 because why? F prime changes from positive to negative. Okay. What about a relative min?
We don't have one.
Okay, so then we would say, let me semicolon here, squeeze that. F has no relative min, or how about we say it like this, no relative extrema, because we have to talk about the critical number, extrema, at x equals 0 because F prime has the same sign. You had to include x equals 0 somehow. Okay, so you can't really talk about a min because it could have been a max too. I don't know.
I don't think I've ever heard it smaller.
Wait, you said